Susan's method, and I want to remind you what Susan's method was. She's saying that she can determine the probability by using combinations. So 3 choose 1, 4 choose 2, etc. And in our page 884 that we're working on, there were some scenarios that I thought it'd probably be a good idea just to confirm she's right again. And so I went through what would it be if Walter made 4 free throws, shot 4 free throws, and missed or made or what variations of it. So take a look at this list. Please don't copy it down. Just kind of see if you can see a pattern and if you trust that I've captured every scenario. I think I did, but you make sure for your own benefit as well. So here it is. We've got all 4 misses. There's 0 misses. There's only one way that could happen. We've got making at varying stages, either in the beginning or somewhere in the middle or towards the end, and there are 4 different arrangements for that happening. Or we've got making 2 things, making 2 shots, making 2 shots, making 2, making 2, and I came up with 6 ways that could happen. Or it's make in 3 ways, with missing occurring in different stages along the way. And there are 4 separate ways where he could have made 3 but missed one of them. And there's only one way he's going to make all 4 free throws. And so with that in mind, I want to use these numbers, this 4, the 6, and the 4, and just check if Susan's method of using combinations actually does work. Okay? So let's go back and take a look at the question. Walter is making 1 out of 4 free throws. And Susan's method says use combinations multiplied by the probability of missing and making and how many times he misses and makes. And then from that, we can get the probability. Now, unlike question 1, where we had worked it all out by hand, now we just have to trust that her method is right, because we did kind of confirm it on page 883 that it does work. You can use the combinations and the probability of makes and misses. You have to have all of them. And then that will still give you the correct probability answer. So let's just see right here. Walter making 1 out of 4 free throws with Susan's method means we need 4 choose 1. I think 4 choose 1 is 4 shots, making 1 time. There's 4 different ways that could happen. But let's just confirm from calculator time. I'm going to use the formula first, all right? So bring that up and bring this up. So the formula for 4 choose 1 is 4 factorial over 4 minus 1 factorial times 1 factorial. So I don't want to rewrite all. I'm going to rewrite. I'll write it this way. The probability of a make is 2/3, and the probability of miss is 1/3. But from the list, we can see he's going to miss 3 times. So that's 3 probabilities of 1/3, which is why our exponent is 3. 4 factorial is 4 times 3 times 2 times 1. And then 4 minus 1 is 3 factorial. So 3 times 2 times 1. 1 factorial is just 1 again. And then the 3's cancel, the 2's cancel, the 1's cancel. And when you're dividing by 1, that doesn't even really matter either. So yes, the answer to this 4 choose 1 is 4. Confirm with the calculator though. Menu 5, that's the probability menu, 3. And we're going to do 4 choose 1. And it's 4. So there's consistency from the list where I listed all 4 different ways he could make 1 free throw. And then how the combinations calculation also produces 4 different ways Walter could make 1 free throw. And then we have the calculator. And in the calculator, we're looking at how 4 shots, making 1 of them, there's 4 different ways to do it. So there's this consistency of 4. Susan's method is working. Now we need 4 times 2 times 1 times 1 times 1. And on the bottom, 3 times 3 times 3 times 3. This turns into 8 out of 81. Let's just check that over here. I'm going to go entirely all of it over here. NCR. And then 4 choose 1. I know it's 4. I could have just typed 4. 2/3 times 1/3 to the 3rd. 8 out of 81. I think I did that exponent wrong and I got lucky. Okay, parentheses matter. So 4 times parentheses 2/3 times parentheses to the power 3. I got lucky. I got lucky because this is bad math right here. This is wrong. You're not supposed to put the exponent like where I did. This is the better math. If you can see it, can I zoom in? I don't know. But the point is that this is right. We have 8 out of 81. So why don't you try C, D, and E and just see if you can get the same answers that I do. And I'll do less explanation because I feel like I've done all the explanation that's necessary. Go see if your math and your math calculations and thinking match the results that I come up with, okay? Let's go. 4 choose 2. I got 6 from 4 choose 2, NCR 4 choose 2, that is 6. And then I've got probability of a make, so 2/3 squared times miss, 1/3 squared. So then all of that goes into the calculator, 6 times 2/3 to the power of 2 times 1/3 to the power of 2, 8 out of 27. Okay, I'm not talking to you right now. I'm talking to myself and I'm talking out loud. So if you're following along right now, I actually encourage you to stop to work these out and maybe skip forward like a minute or two, or skip all the way to the end and just see if your answers all the way work. Do that because you did the math yourself. So pause and you do the math and then compare our answers. Okay, so I know 4 choose 3. There's 4 different ways he could have shot 4 free throws and made 3 of them. These are the 4 different ways that could have happened. So 4 choose 3 is 4. Let's confirm it though. NCR 4 3. Yep. Now the probability of a make is 2/3 and it's cubed. And the probability of missing is 1/3 and it's technically got an exponent of 1. So I'll write the 1 down, but it's not really going to change the calculation. So then I have 4 times, let's go, yeah. 2 divided by 3. Oh, come on now. 2 divided by 3. Close it to the power of 3 times, nope, move out to the here, times parentheses 1 divided by 3, 1/3. 32 out of 81. Okay, last of all, there's only one way to shoot 4 and make 4 times the probability of 2/3 to the 4th power, which I know is 16 out of 81, but let's just confirm it. So NCR 4 4, 2/3 to the power of 4. What are the events mentioned in the opening statement? What number of free throws is Walter most likely to make? Which part of your strategy stays the same for 4 free throws as opposed to 3 free throws? Which part of your calculations is different? Does it make a difference what order you express the makes and misses? No. Why not? And how can you check that your work is correct? It doesn't make a difference how we express the order of makes and misses because their probability here would be 2/3, 2/3, 1/3, 1/3. And in the next row down, 2/3, 2/3 in a different location, but still 2 of them, and then 1/3, 1/3. So you're getting the same probability out of any of these 2 make scenarios. There are 6 of them. So the calculation, 2/3 for making it twice, 1/3 for missing it twice, 6 different arrangements of that probability happening. It doesn't matter how you calculate the probability in the order that you calculate it. You just got to know how many times it shows up. 4 choose 2. 4 things, choose 2 of them, happens in 6 different ways. Thank you for watching this video. This has been Activity 1. I'm just going to search forward again. Activity 1 continues in the next video on page 885. So I'll see you there. See you in the next episode.